Welcome back to the Cloud Monkey Room. It's my pleasure to introduce you to Abhisar, my colleague, and he'll be talking about shared file systems.
Hello.
Applause.
Hello, welcome everyone to this talk on shared file systems. A little about me. I'm Abhisar. I live in Delhi, India. I'm a software engineer at ShapeBlue. For a long time, I worked in NetApp. I joined ShapeBlue last year, and since then, I've been involved with CloudStack. I have a toddler, and lately, I've been dealing with lots of temper tantrums. So that's it. So diving straight into the topic, shared storage for instances. So CloudStack has traditionally been just an IaaS. We haven't delved much into providing upper layer services to the users, like giving shared storage for instances that CloudStack provisions. But hyperscalers and other open source cloud providers have had these solutions for a long time. And as we have more and more people looking at CloudStack recently, it would be good to fill those gaps. And I think this is a key piece that was missing. So CloudStack didn't have any shared storage solution until we did object storage as a first-class feature in 4.19. So file share as a service or shared NAS is another such feature in the same category. So while object storage has its own use cases, but file share is more performant and more collaborative in nature. So it has its own benefits. So the use cases for shared NAS can range from anywhere from web hosting, databases, email servers, logs. It can provide shared storage for containerized applications. It can help with data analytics, CI/CD pipelines. So as I mentioned, other hyperscalers and providers have had this solution for many years. So you can see OpenStack, Azure, AWS, and Google Cloud. So NetApp is actually the biggest contributor to the Manila project of OpenStack. So that is their file share as a service. They did it because they had customers who wanted to use NetApp boxes with OpenStack. So CloudStack didn't have a solution. So earlier this year, we got together with some of my colleagues at ShapeBlue and to design and implement such solution. So what was required if we want to implement this? First of all, the solution should be easy to set up and manage. And this solution should be meant for the users with minimum admin intervention. So a user or tenant should be able to set up and manage the shared file service. It should be highly available. So it should support concurrency. So multiple instances should be able to connect to the shared file share and use it. You can do parallel read and writes. It should support some kind of usage and billing. It should support backup and recovery, and it should be scalable. So you can increase the size or the compute as required. So this year, we implemented this solution, which we call as a shared file systems. So you'll see a new section here on the UI. In the storage section, you'll see a new tab called shared file systems. So what is a shared file system? It's a CloudStack managed NAS service. It supports NFS. It is self-service, so a user can create the shared file system by themselves. It's very easy to use. It has standardized API support, so a user can also create automation to create and manage the life cycle of the shared file system. It's completely hypervisor and storage agnostic. So any hypervisor you have, you can create this, and you don't need, for example, you don't need an NFS server for this to work. You can have any storage, and you can deploy this on that. It works out of the box. It's a turnkey solution, so a user can just use the simple API in the UI to create the file share. although it works out the box, it's still configurable to a large extent. And it is written based on a framework plugin model. So currently, the plugin we have is managed by CloudStack. But in the future, other storage providers can be added as a plugin to this framework. It's releasing with 4.20. I don't know if you can see that, but we added it into 4.20, which is up for release. So it will be available with 4.20. So let's look at the architecture. So we have a management server here with hypervisor, stores and host and bunch of primary storage. So when you create a shared file system, CloudStack will orchestrate and create an instance which will be connected with two volumes, one root and data. These can exist on any storage. So data will contain the actual file share data, which will be used by the users. And instance will serve as an NFS server. So the process of creating a file share, there are some API parameters that the users will provide. These contain network, the network to which the file share will be connected to. Then users can specify file system, which will be installed on the volume, data volume. So currently there are two options available, ext4 and XFS. Users can specify disk offering for the data volume, size, encryption, QoS, other things like that. Whatever is present in the disk offering we have currently. And user can specify compute offering for the shared file system instance. Shared file system instance uses a system VM template. And we use user data to push some scripts to the shared file system instance. And Cloud Init will use that, and it will install the file system as mentioned, either ext4 or XFS. It will configure the NFS export, and it will set some automatic rules for resizing and addition of networks. So let's say we have a few user instances connected to a guest network, and they want to use this shared file system. So there are several ways to do it. One is you can attach the shared file system to the guest network when you are creating the instance, and users will get access to it. You can use you'll get an IP and how to mount it, and you can mount it. Other way of doing could be there is a guest network, but let's say we want to give access to only a few instances to shared file system. So what we can do is we can create a separate storage shared FS network and then connect only those users which are required. So that is another way to do it. Feel free to stop me at any time if you have any questions. So let's look at the features. I've talked about them before also, but it's good to reiterate. So it supports NFS for now, but we can add, yeah.
Are there plans for GIFs or SMB?
Yeah, I mean, in the future it will be good to have. So we are not actively working on it, but if there is demand from the community or someone wants to collaborate to add the feature, that can be done. But currently it supports NFS only. So it has support for isolated, shared or VPC-tier networks. You can create it in any of these. It supports volume snapshots. It supports backup and recovery of the instance. It is hypervisor and storage agnostic, as I have mentioned. It has ext4 and XFS backend. The disk offering is configurable, so you can add whatever options you want. For example, you can have storage tags so that you want the shared file system data to go to specific storage, you can add that. Compute offering is also configurable. So there is a minimum requirement for compute offering, which we have. So it's I think 2 CPUs, 1024 RAM, and it should be H enabled. So you'll get high availability using that, and you can configure it as you want. It has inbuilt support for users and billing. Since we are creating it's like a user instance and a data volume, so it will come from there. Similarly, resource limits will also apply. Okay, so we can, I think, jump straight into the demo. What I'll do is, for the purpose of the demo, I'll create a very simple WordPress website. So I have two web servers behind a load balancer. I have an MySQL server and a shared file system. So shared file system will contain the WP content directory, which contains all the static content, themes, and plugins which you installed into the site. So both these web servers are connected to that via the SNet1 network, and they are connected to MySQL server using a different network. Let me show you. So to not take too much time, I've already created the web server instances and DB server. I've configured DB server. And in the web servers, I have installed the required packages, and I have downloaded WordPress site. So WP content has some data, but this is local to this server, and this WP content is local to this server. They're not sharing it. So what we'll do is we'll create a shared file system and mount it at WP content location. So before it, I also want to create the SNet2 network. So let's do that. SNet. Okay. So you'll go to this. I can go to this section, create shared file system. File system is XFS, network, disk offering, and compute offering. What we also need to do is add this network to the instances, to the web server instances. Okay, let this work. So when we open a shared FS view, you'll get some details. It will fill up more details when it is created. So it will have the instance name, the volume, and other fields. And there is an access tab will also be filled up, and the network tab. You can also see these the shared file system instance which is created and the volume in the instances tab and the volume tab. So if you see here, a shared FS instance is created and it's starting. And if you go to the volumes, you see two volumes created here associated with this instance. So let's just wait a while this gets created.
Shared file system instance is created using the system VM, right?
System VM template, yeah.
So is it should it be shown in the user instances or system VM?
We are showing it as a user instance because user has complete control with it.
It will be confusing maybe. We can keep it in
But
system
it's
VM.
similar to like CKS VMs.
Yeah, it's
like Kubernetes VMs we also show in user.
yeah, they also
and
have
they
system
use
VM template.
Mm.
Yeah, so it's created. You can see the network it is connected to, the instance volume and what else, details, and sorry, I'll go to this is the instance view, and this is the file share view. It also has an access tab where you can see how to mount it. One thing I didn't show you is the guest network, and so this is the public IP address, and we have a load balancer here, which is behind web server 1 and 2. So we'll use the access to mount this. So before, what we'll do is let's back up this directory. Oh, sorry, WP. Create new directory and mount this here. So this is mounted and this is shared, served by the file share. I'll copy the content of here. Also will do the same thing. Just mount it. Sorry. Yeah. So now, okay. So it got copied here, and both are pointing to that. Let's go to the public IP and just access the site. So this is the public IP. Yeah, so I can now create it, and let's just put something. Yeah, so the themes, plugins, and any static image or video content is served by the file share, and the load balancer is on round robin algorithm, so it's going there. So let's just apply a theme, and if you apply a theme, you can add a new theme, and it will use the shared file instance. Oh, okay. One thing I have to do is I have to set the correct user. Same thing here. Now it should work. Yeah, it's installed. Let me just add a static content just to verify that it goes there. So let me add some images I have. So if you see new directories uploads have been created because we uploaded the so both of these are serving the same static data. Just to finish up on the file share, there are some lifecycle operations that are available. Like you can update the name, description, stop, restart, change the disk offering, and once you stop it, you can change the service offering as well. So you can resize it by changing the disk offering. If you go to the instance and go to this instance, there are some additional options that you can have. So here you can assign it to a backup offering for backup and recovery. And if you go to the volume tabs, there are some options there as well. Like you can take snapshots and things like that.
Is the restart of VM same as the restart in the file system?
Yeah, it's same.
Both are same.
Yeah.
So just restart the
Yeah. You can also do, yeah. Sorry.
So, if you need to provide multiple shares to the same user, do you need to bring up several file share instances, or you can add additional shares to the same virtual machine?
If you want additional shares, you need to create a new file share instances. Yeah.
Is possible to use for databases?
Yeah, you can use it for database. You can install database on the volume, and
Okay,
it will be
thank you.
shared. Thank you.
And can you do a live resize of the share?
You mean automatic resize?
No, manually,
Live-
but live resize.
Yeah, live resize
without
you can
restarting
do.
the
You can do
DMK
live
service.
resize. Yeah, you don't need to stop for resizing.
And what happens if the VM gets corrupted?
So you mean the user data or just the VM
Just the
config?
VM.
So there is an option. So VM is stateless.
Mm-hmm.
So an option is restart with cleanup. What it will do is it will
Is
restore
it like the same VR feature?
yeah, same VR
Yeah,
feature.
same VR
similar,
feature.
yeah.
Okay.
Yeah.
You can destroy it, and it will be mounted with the same
Yes.
file system.
Restore it to the original template.
Thank you.
You had a question?
Yes. I'm missing the option just to attach the virtual volume to two instances or more instances. I don't want to use the NFS as a mount as a service, but I just want block storage just used by two instances.
Block storage,
Yes.
CloudStack volumes. I don't think that is supported currently.
May I try to answer this?
Yeah.
May I try to answer this?
Yes. Yes.
So sharing a block storage between multiple instances is not so easy because there are very few file systems and applications that can support this. And one of the main issue with this is first you need a shared disk file system like OCFS2 or GFS. And the other thing is you need to your storage layer and the hypervisor to provide some persistent reservation mechanism that's required for locking.
Yes. Yes. But we have scenario to make a Oracle database.
Okay.
With two instances. The Oracle software is taking care of the locking. There is a clusterware, for example, ASM.
But it requires, I think, persistent reservation on iSCSI to do this, on SCSI.
Okay.
That I'm not sure KVM Virtio block supports this. Maybe KVM Virtio SCSI supports this. I'm not sure.
Because directly on the hypervisor, there is an option to attach a virtual disk.
We can, if you like, we can discuss this because it's a different topic than the main.
Okay, thank you.
I'm available.
Regarding high availability, so there's only one VM. If it fails, so it's not really high available then, right?
Yeah, I mean, it follows the HA that you have for other user instances. Like it will create a new instance. So it will have some downtime. I guess it's not like, you have two nodes parallelly serving it.
Okay. So normally the client should catch up with the downtime is so small, or are we talking seconds, minutes?
I'm not sure. Bobby, do you know?
NFS is handling it. So we'll install the file and then we'll reconnect the NFS client to take care of it. It depends how long it will. Sometimes you get errors. But this is NFS, right? Then
Yeah, it generally uses the high availability defined in CloudStack. So whenever you have a failure of a VM in CloudStack, if it detects that there's no operations on the disk writes and it's not pingable, that sort of thing. So it will create a new VM. But there will be some downtime, but the idea is not to have like 100% uptime, but if you have something down, basically to bring it up somewhere else. That's the general idea.
So does it support L2 networks, VPC networks, or is it only?
It supports VPC tier L2 network. We haven't tested, but it might work. I am not sure.
I don't think it supports L2. I'm not sure.
Yeah,
Is it possible to do some NFS settings?
Yeah, so you can access the instance which is created. So with it's set up with already whatever is set, but you can modify it if you want. You can go to the NFS etc exports
on the virtual machine itself.
on the virtual machine itself. Yeah.
Through CloudStack API, there
Through
is no API to
SSH, you can access the.
No, there is no CloudStack API that you can change the NFS settings.
Yeah, there's no API, CloudStack API. Yeah. Okay, I have one more. Yeah.
Just one question. It might be off topic totally here, but what about using like Minio and S3 storage and then Fuse and mount it on the nodes? Would that be possible for shared storage? I don't know.
I didn't really get your question.
No, I think it's storage agnostic. So if that storage is supported in CloudStack, it should work. So it's a matter of if the primary storage is supported, so it should work.
Yeah.
Can we finish the slides and yeah, sorry.
So I'll go through it very quickly. It's just what is missing. So more protocol support as we talked about. ACLs-based access, currently it is possible, you have to go to the instance and do it. As we said, it's not, no API support is not there. FS block size currently is 4K, but it can be configurable for according to use case. It can support auto scaling. Currently you have to increase the size using the API manually or the UI. From volume snapshot, currently we cannot create a new shared file system. Like you can create an instance from a volume, but it will not be a shared file system serving the data. We cannot move shared file system to a different account and project. So all these, currently it is not planned, but we are looking for community support. If there is a demand or use case, we can do it together. And more storage vendors can be added because it's a framework support model, so it's required. So yeah, that's the slide. We can go back to questions.
All right.
Is there some kind of health checking, like for the virtual routers for the NFS service? So does CloudStack know if NFS is still working or the
no,
machine is
CloudStack
working?
won't know. So there is no contact between management server and the. So it can be done via the virtual router, but it's not implemented.
Okay.
So if it's not mounting, then there is some problems there.
So this is a question tied to the AJ. So what about the failure of the volume itself? If like a storage becomes unavailable, what happens then?
That should be similar to how normal user volumes are there. I'm not sure how it works. Does anyone know? They can answer.
So is there some kind of replication of that
No, there is no replication.
If it dies, it's gone, basically.
Yeah.
Yes, but if it's manual.
Can be. Yeah, storage provider maybe can handle that.
Okay.
It depends on the storage provider, yeah.
Was this a question about the backing storage, primary storage that backs the...
Yeah, primary storage goes down, yeah.
You have a question?
No, he was just
talking. Just coming. Oh, yeah.
I think Steven is.
You again.
What is the goal? Is this to provide a service inside CloudStack, or
yeah?
Okay.
So the
because
goal
then
is
should we proceed more the API way? If it's a service, we should able to do everything via API. In my humble point of view.
Yeah.
So it should be. For me, it's more important to have the API. Instead of having more protocols or more storages.
API
like
for
SMB
configuring
and
NFS
like
export, you mean?
Yeah, so
yeah.
I was only curious about what is really the goal and what is the purpose behind it.
Yeah.
Because roughly speaking, this is you spin up an NFS server,
yeah.
you install NFS on it, and you can mount it manually from other VMs, right?
Yeah. So the one goal is making it very easy for the user, for the tenant. So they can do it themselves. They don't need any other configuration. And as you mentioned, API access. So this is just the first iteration. There are many things missing. And what you are mentioning, if it is very it's very good to. It will be very good to have, and we can do it in the future. Yeah.
So I think the idea is to have. It's basically a first-class citizen on the CloudStack layer. So you have this mount that is treated like a regular object in CloudStack, and you can do whatever with it. So, and you have APIs for it. So. But if you want to use it, obviously you need to mount it.
Yeah.
All right. Any other questions? Yeah.
Is there any separate usage type for shared file system, or is?
No, there is currently it doesn't have a separate usage type.
All right. Very good interest.
Thank you, everyone.